Good evening.
So you're going to be doing a lot of
I
talking.
wish to welcome everyone, hope you can hear me, to the Jericho Historical Society's symposium on the 150th anniversary of Wilson A. Bentley. It's very appropriate. He was born on February 9th in 1865. I'm delighted, too, to see such a huge turnout this evening. I'm sure he would be surprised also. The weather, of course, is appropriate. I want to thank, before we begin our proceedings, and a few thank yous and introductions here, formalities, to remember Blair Williams, who we might say put Wilson Bentley, Snowflake Bentley, back on the map for us. Blair began in the late 50s, early 1960s to restore or revive or to remind us all of the importance of this remarkable man from Jericho Center, from Nashville. Then Blair continued with this energy all through that period, lecturing around the state of Vermont, and of course culminating in the Bentley Museum here at the Jericho Historical Society's building at the Old Red Mill in Jericho. Then we were also fortunate in Jericho. A few years later, the Miglianicos came to Jericho from New York, and Ray Miglianico took up the mantle, and he helped a great deal with the Bentley Museum, setting it up. But more importantly, Ray, as many of you are familiar with his Vermont Studios activities, has each year prints a very selected edition from our Jericho Historical Society collections and also from the Buffalo Museum of Science, the micro photograph images that Bentley had made many years ago. And they're recognized, of course, collected both nationally and internationally. Thank you, Ray, for all your efforts, and Louise, too, for supporting us. I want to thank first this evening, of course, the Jericho Elementary School for allowing us to use their splendid facility, this auditorium and gymnasium. To Lucien Lapierre, who's been extremely helpful and supportive of our efforts this evening. He sort of is kind of the headmaster, if you will, of the elementary school and keeps it in splendid condition. I also would like to mention that this evening we have special birthday cakes, which courtesy, well, they helped us, the Harringtons folks down in Shelburne, whom I've known for many years, have produced these marvelous birthday cakes, which we'll all enjoy here in a little while. Mark Breen, I don't think I need to introduce Mark to many of us here. This is Mark Breen's fourth trip to Jericho. So there's a strong relationship between the Fairbanks Museum and the Jericho Historical Society. Mark was here years ago to celebrate the 125th anniversary of Wilson's birth date. And then he has spoken twice in recent years, as many of you are familiar, at the Old Red Mill in Jericho, at the Jericho Historical Society's Distinguished Winter Lecture Series, which I'm sure many of you, of course, have attended these past few years. Mark will introduce our panel, which we're very delighted. And if I, on a personal note, want also to thank the Bentley Anniversary Committee, which helped put this splendid event together. Catherine McMains, the Select Board Chair of the Town of Jericho Select Board. Ann Squires, President of the Jericho Historical Society. Orlin Emerson from the Jericho Community Center Board, and myself also on the board of the Jericho Historical Society. Well, we're about to begin our events, but one, as I mentioned, personal note. This past fall and early winter, when we were finalizing our speakers to be on part of the panel on this symposium, I rang up each of the speakers, as you can see their names in the program, and I was very pleased and honored by the response. They all were extremely enthusiastic and delighted that we're having this occasion this evening. Last but not least, I want to mention Jericho's. I used this phrase the other day on the Vermont edition on VPR on Professor Mary Jane Dickerson. She, as Blair, taught for over 35 years at the University of Vermont. And again, I will repeat my sort of phrase. Mary Jane is our Jericho's Poet Laureate. Last fall, I commissioned her to write a poem about Bentley and his life and his efforts, and she will read that poem to us graciously just before our winter musical interlude by our cellist and violinist, John Dunlop and Laura Markowitz, with the Vermont Symphony Orchestra, but they live here also in Jericho. Well, I think everyone is settling down, so I think it's time for us to have official greetings from Catherine McMains, Chair of the Jericho Select Board. Catherine?
Well, theoretically, they said the microphone will pick my voice up, so. On behalf of the Select Board of the town of... Use the hand mic instead.
Yeah. I think it's on. You
Okay.
try.
All right, here we go. On behalf of the Select Board of the town of Jericho, I want to thank everyone for coming out tonight, and to thank the Historical Society for the work the committee has done to be able to put on this symposium. The town appreciates and has worked with the Historical Society to preserve the Bentley legacy. Together, they secured the placement of the state historical marker in Jericho Center. In every small town in Vermont, we find very fascinating interconnections. For instance, I live on Bentley Lane, and a noted artist lives in the Bentley home.
Put your hand up.
Nobody can hear, huh?
We're almost done.
That's right. Well, it's not like a town meeting when it's right in front of me. For instance, okay, so. How? This? Right here?
Yep, that's it.
This is hard. I'm not going to start over, though. For instance, I live on Bentley Lane, and a noted artist lives in the Bentley home, which he would love, as he had a passion for beauty, especially the art in nature. Wilson Bentley and his legacy is also important to the town, as the town logo features the iconic red mill, which houses the Bentley Museum, and it is backed by a snowflake. People come here to learn about Bentley, but also then find out about our wonderful town and all it has to offer. And now back to Brooks and the Bentley family.
Thank you. Thank you. And one of the direct descendants of the Bentley family is going to make a few remarks for us this evening. There you are.
I think my voice carries well enough that I can probably get by without the microphone.
No,
There, go ahead.
Okay. I'm Sue Richardson. I am Wilson Bentley's great-grand niece. My grandmother, Amy Bentley Hunt, Willie's favorite niece, grew up in the Bentley home along with her 7 brothers and sisters. Her parents, grandparents, there was 3 and sometimes 4 generations living in the household there. And I want to thank Brooks and Ann and the Jericho Historical Society on behalf of the Bentley family for putting together this wonderful celebration of Wilson's life. Quick, the first flakes are falling. The couriers of the coming snowstorm. Open the skylight, and directly under it, place the carefully prepared blackboard on whose ebony surface the most minute form of frozen beauty may be welcomed from cloudland. Those words were written by Wilson Bentley in 1901 as part of an article for Harper's Magazine entitled The Story of Snow Crystals. As a child growing up on my grandparents' farm here in Jericho, my grandmother told me many stories about Uncle Willie, about his work, about his sense of humor, his love of practical jokes, and about life on the Bentley farm. We always thought of her as kind of the family historian, but in retrospect, she actually knew very little of the family history beyond her grandparents, Edwin and Fanny. In his biography of Snowflake Bentley, Duncan Blanchard noted that Willie apparently had little passion to understand the origins of the family. Duncan detailed the history back to William Bentley, born about 1680 in Massachusetts. And while much has been written about the Bentley history, little has been said about the other side of the family, the Coltons. We know that Willie's mother, Fanny Eliza Colton Bentley, was his greatest supporter. 20 years after her death, Willie is quoted as saying, "All that I am or that I ever shall be, I owe to her." The Colton family roots in America go back 8 generations before Willie to Quartermaster George Colton, who arrived in Massachusetts in 1644. Fanny's grandmother, Sarah Lurvy, also had deep roots and some tragedy, including her three times great-grandmother, Susanna North Martin, who was accused, tried, and hanged for witchcraft in Salem in 1692. Fanny's mother, Susan, she's a bit of a mystery. Though the history of Bolton says she was born in Jericho and that she and Moses were married here in 1825, there's no documentation of that whatsoever. But my grandmother always told me that there was Native American in our lineage, and I've come to believe that that was Susan, Fanny's mother. Marrying someone of Native American ancestry in 1825 was not a particularly popular thing to do, so I suspect that may be the reason that there wasn't any documentation of the marriage. We do know, though, that they spent their lives in Bolton. Fanny and her brothers and sisters grew up there. Fanny was a school teacher, and in Fanny's parents' will, there were 2 just very interesting things of note. First of all was a library was mentioned in the inventory. Not something that was very common in a private family in the 1870s. And of particular note, a bequest to Fanny from that library of the New American Encyclopedia. In Gloria May Stoddart's biography of Uncle Willie, entitled Man of Science, Man of God, she mentioned early in the book about Willie searching for answers in the encyclopedia to his questions about nature, which kind of led to Fanny presenting him with the microscope that he first used to study the snowflakes. The other interesting part of Fanny's parents' will was that when her mother died in 1880, there was a bequest in the amount of $100 to Fanny. By the time the will settled and the estate settled in about 1881, isn't it interesting that that turns out to be the exact amount of money that Fanny and Edward needed to come up with to purchase the camera and microscope? Such an extravagant expense, about $2,500 by today's standards, for 17-year-old Willie, which secured his place in history. Willie's story has been documented many times, his struggles to perfect his technique, along with the personal struggles to gain acceptance within his community and even within his own family. His father and his own brother described his messing around with snowflakes, wasting his time, and the people in the community seemed to think he was a little cracked. But he persevered. And shortly before his death in 1931, his lifelong dream came to fruition with the publication of Snow Crystals. In April of that year, in announcing the upcoming publication, Willie wrote, "It will serve to further increase the fame of Vermont's marvelous snowflakes and to give added millions of people the chance to see them and be thrilled by their beauty." Willie died on December 23, 1931, at 66 years old of pneumonia. I have to wonder if he ever imagined that in 2015, 83 years after his death, people the world over would still be interested in his work, would still appreciate the delicate beauty found in each individual snow crystal. Perhaps he did. In 1924, he wrote, "Nature's storehouse of these fragile jewels appears to be inexhaustible. In all likelihood, 10,000 years from now, snowflake collectors will still be discovering forms new to science and never before seen by mortal eye." Willie's life work was the study of weather and all forms of water, rain, frost, dew, and in particular his beautiful snow crystals. That his work still endures is a testament to the dedication and passion of a humble Vermont farmer who wanted nothing more than to share his discovery with the world. As he wrote in 1904, "The snow crystals come to us, not only to reveal the wondrous beauty of the minute in nature, but to teach us that all earthly beauty is transient and must soon fade away. But through the beauty of the snow is evanescent, like the beauties of the autumn, as of the evening sky, it fades but to come again." Thank you very much.
And now, Mary Jane Dickerson will read to us her poem about Wilson Bentley, which many of you will find as an insert in your program. Thank you, Mary Jane.
After all those fine words. Is that?
Right up to you, Jim.
Right up to Jim, right here.
Yeah,
Okay.
that's right.
Okay. After those fine words from the Bentley family, I'm not sure you need the poem, but here goes. I would like to thank the Schulenbergers for allowing me to see some of the things that they found in the Bentley house that I was allowed to handle, look at, and sort of feel as if maybe a little of the DNA was still there that I was able to touch. And I'm so appreciative of the special collections at the University of Vermont, the Bailey Howell Library, and it's not right, my chin?
Yep.
Right there, sorry. And I so appreciate all the times I was able to go to the Old Mill Craft Shop and just stand in that little museum room and take that in. I have to read from my copy of the poem because the one as printed in your program is too small for my eyes. Obviously, Bentley had much better eyesight all his life than I probably do right now. The title of the poem is "What Falls from the Sky?" for Wilson A. Snowflake Bentley on his 150th birthday. From his Vermont birthplace in a farmhouse along Nashville Road, its sharp curves and straightaways running the length of Millbrook Valley, Wilson A. Bentley grew up surrounded by fields and pastures, with February's softly mounded snowfalls brimming over the tops of stone wall fences to create a landscape rimmed by nearby forested hills, mantled in white, where he could wake up to ice flowers blooming from window pane frost, to see Bolton Mountain wreathed in winter's cloud-filled skies. Into Jericho's rural quiet of ice and snow, a marriage of land and sky. Wilson A. Bentley was born a son of the soil, as much as a son to those who gave him life and bore him, while far to the south the last cannons were firing their final shots into knots of horses falling onto the men whose bodies they had just borne. Here, a farmer's son, never to be sent to war, a sharpshooter in a Vermont regiment, could choose to stay, working the family land, gazing upward through his telescope at what the night skies revealed, observing close at hand during daily chores what each season brought to life. His slight figure bent into the winds, walking to the nearby district school for its occasional sessions, then the miles to Jericho Academy. Yet, from the beginning, he was his mother's prize student of all crystalline forms of water, making their way from the skies above to sparkle in dewdrops caught in spider webs and unfolding dandelions, to fall as raindrops in a summer shower, dimpling the surface of nearby Mill Brook. Later, to trace autumn's golden leaves with hoarfrost before the coming snow. His 15th birthday saw a boy bent over the magic of an old microscope, bringing to life the wonders of all he'd marveled at in fields, woods, and streams, bringing to his naked eye new worlds to draw. The design of a butterfly's wing, the shape of a shamrock leaf, the geometry of rock crystals gathered from a nearby hill, and the elusive intricacy of the evanescent snow crystal. This simple instrument magnified the surrounding natural world, transforming a farm boy into Wilson A. Bentley, self-taught scientist with a poet's voice, a cloud physicist before such existed, obsessed with the fragile beauty of common things, the miracles of nature's minute creations, who would one day be the first to capture a delicate snow crystal with a bellows camera attached to his microscope, mounted onto a wooden table in the frigid air of the family woodshed. There, at 19 years of age, in a laboratory sharing space with cords of stacked firewood, Wilson A. Bentley caught on a small black tray and photographed through his microscope on January 15 of 1885, the first of thousands to come, of the only crystals whose home is up among the dark cloud regions of the storm, where silence reigns supreme, where frost is king. Up there, within free air, snow crystals tumble, collide, and adhere to others as they fall to earth from on high, where they begin their journey through vast reaches of space, creating elegant, six-sided miracles of design, the building blocks of snowflakes fashioned into geometrical shapes clustered around a nucleus. From this woodshed laboratory, Bentley traveled widely, speaking from handwritten lectures, sending photographic plates of snow crystals to the Smithsonian from his fear of fire and lightning or accident here at my home, and publishing accounts of his discoveries to circulate around the world. A few Vermonters still live who recall Snowflake Bentley's visits to their classrooms. Born into a snow-filled world, the snow poet scientist was borne away after walking home through a December blizzard of what he had once called the gems from God's own laboratory.
Thank you, Mary Jane, for your very fine and appropriate tribute to Snowflake Bentley. Now we'll have a musical interlude, and Bentley sang in the choir of the First Congregational Church in Jericho Center for most of his life, and he also was an accomplished musician, particularly with the violin. So it's with great pleasure I present to you two Jericho musicians, a violinist and a cellist, who play also with the Vermont Symphony Orchestra. They're going to provide our musical interlude this evening. John and Laura. Thank you. Now we're at our symposium, and Mark Breen will be the moderator, as you'll note from your program this evening. And we're delighted again to have all of our guests with us. They have come from long distances for Vermont, from Granby, from Coventry, and St. Johnsbury, and of course Underhill Center. So we're delighted to have this panel to further elucidate everyone on the remarkable life and career of Wilson Bentley, a native of Jericho. Mark?
Thank you, Brooks. And let me just briefly introduce our panel here. I have on my immediate right and your left, this is Dr. Bruce Berryman from the Atmospheric Science Department at Linden State College. And next to him, we have John Miller, Professor of Photography and Digital Imagery at Johnson State. And a colleague of mine, Paul Sisson, from the National Weather Service in Burlington. He's the Chief Science Operations and Operations Officer. Close enough?
Close enough.
That's the right letter. Okay. And I'm Mark Green. I do some of the weather forecasting of Vermont Public Radio on Eye in the Sky. And so I thought what we would do is each of us will speak just for a few moments, a little bit about sort of our connection to all of this. And then we'll both exchange ideas, but also welcome questions from you as well. So briefly, I just wanted to let you know that prior to coming to Linden State College, I really didn't know much about Wilson Bentley at all. But while at the Fairbanks Museum, I was looking for information about water. Water's a great class to do for some of our visiting school kids. So it was very interesting when I tripped across a book called Water Wonders by Gene Thompson. But the interesting thing was that contained in here, and this, by the way, is subtitled Water Wonders Every Child Should Know, the style of which I think is probably challenging to some of our high school students these days. But nevertheless, this delightful book has 156 images from Wilson Bentley. Not only the snow crystals, which you might expect, but because this is a study on water, there are marvelous photographs in here of spider webs delicately laced with dewdrops. We have images in here of frost patterns on windows along with all of the snow crystals, and just some delightful writing. And so she came to Jericho several times to work with Wilson Bentley creating this book. So this was kind of my introduction to Wilson Bentley and his work. And then, and I don't know how many of you, I hope many of you have been to the Fairbanks Museum, but if you hadn't, you can often turn around the corner and just find something you didn't notice. Now, this would be hard to imagine that I didn't notice this initially.
Yeah, if you want to just hang on to it, sure.
Okay, so here I have one. I kind of spirited this away from the museum for the evening. I didn't think anybody would miss it. But we have here snowflake images from Wilson Bentley. There are actually 4 of these at the museum, and they include notes from his journals about the different storms and the kind of crystals that they were producing. And so not only did I have an interesting book written in the early 1900s, over 100 years ago, but now I'm looking at images that he made, that Wilson Bentley made. And these are some of his earlier works. These go back into the 1880s and 1890s. And in fact, the lower section right here, those particular snow crystals from one of the most famous New England storms of all time, the blizzard of March 1888. And so this is, not just some pictures that you would see in a book. These came directly to the museum from Wilson Bentley. It's just one of, I think maybe, I don't know how many examples I can think of. You have to realize that even right here on our panel, we have in Vermont, always have had, an amazing density of creativity, of amazing people doing amazing work. And so we're certainly celebrating Wilson Bentley, but we are very fortunate to have some of these people here assembled on this panel that are in their own right, these marvelous treasures from Vermont. Okay. All right, so with that in mind, oops. It's original wood. All right, so let's just take a few moments here. I'm going to let Dr. Bruce Berryman talk just a little bit about snow crystals and so forth. Bruce.
I wanted to pick up on one of the famous things that Bentley said when, after taking over 5,000 pictures and not seeing any two alike, that no two snowflakes looked alike. And a lot of people wonder about that, whether it's really true. I mean, there's so many snowflakes, what's the probability that no two will ever look alike? Well, I wanted to give you just a little bit of feeling for that, and I need a little bit of audience participation for this. First of all, we all need to pretend that we're water molecules. And if you may know that a water molecule looks like Walt Disney's Mickey Mouse head. And so we need to have our head be oxygen and our hands be hydrogen. And you know that water is one oxygen and two hydrogens, H2O. And the way it looks, chemistry, when it all hooks itself up together, so everybody has to do that. I want to see everybody look like a water crystal. Everybody look like Mickey Mouse. You're very good, Mickey Mouses. Well, it turns out that the tips of the ears are negative, and the tips of your chin are positive. And you know that the negatives and the positives like to hook up. So now I need a special assistant, and I would like it to be you. You stand up, please. So you can turn around, take a audience, and now make yourself look like Mickey Mouse. All right, okay. So now, if I'm another water molecule and I want to hook up with this water molecule, the negatives and positives have to go together. So the ears are positives and the chin is the negatives. So what's it going to look like? Well, that continues. And then... Is it gone?
Sort of.
Thank you. And... Hello? Yeah. Hi. Thank you. And so as it gets warmer, the molecules spread apart. As it gets cooler, they start hooking up. And as they start hooking up, they hook up like you and I hooked up. And then as it gets colder and colder, they keep hooking up. And then another one hooks on, and then another one hooks on. And pretty soon, they hook up. And if you noticed, we need you again. Okay, put your ears up there, Mickey. Thank you. Now, when I get on there, notice the angle that I'm at. Thank you. So, the second one was tilted a little bit. And the third one would be tilted a little bit more. And finally, by the time you get 6 of them, they make a circle. And that's then the water molecule after it's hooked up as much as it can hook up. And that's when, now when it gets cold enough that they're hooked up like that, it becomes an ice crystal. But, come on up here again. Now, we have 2 up here, two negatives, another molecule can hook to. How many? 3. Whoa! So how many when there's the next one? How many when there's the next one? Here you go. Very good. It keeps getting more. We started with 2, we had 3, and we have more. And now we have one for another molecule, and one for another molecule, and one for another molecule. Thank you. So pretty soon, what started with 1 molecules, 2 molecules, pretty soon you get lots and lots of them hooking up as the circles keep getting bigger and bigger, and the circles hook together. And we have to remember now that we're atoms and molecules, so we're not very big. And you're going to have thousands and thousands of these layers of molecules hooking together before it even gets big enough that you could even see it. And by then, how many years are there going to be? Lots and lots and lots. Furthermore, they're going to go together based upon temperatures and pressures and humidities. And like every thousandths of a degree, they'll hook together at a different angle, and different ones will come in at different speeds and hook on. And every thousandth of a millibar of pressure, there'll be different forces, and different ones come in different areas. And every thousandth of a percent humidity, different ones come in at different speeds and hook up a little bit differently. So I think you can see that very, very quickly, there's lots and lots of different possibilities for those things to hook up. And it becomes reasonable that there's never going to be 2 alike. It goes geometrically, and it's a lot like people. We all have the same DNA. We all have the same basic structure. 1 head, 2 arms, 2 feet. But all those little pieces of DNA can hook up in lots and lots of different ways. So what do we have here? We have 150 people. Do any 2 of them look alike? Not unless we have a twin in the crowd. And what do we know? We now have 7 billion people in the world, and no 2 look alike, except for twins. So if you think about with people, we don't worry, it's reasonable that we all look differently, because even with the same basic DNA and the same basic structure, there are so many different combinations of all those little human molecules that we all come out looking differently. It's the same thing with snowflakes. All the different angles, all the different pressures, all the different humidities, all the different temperatures. There are many more than 7 billion different combinations that snowflake can turn into. And so it really isn't a surprise that no 2 ever look alike. So, thank you. Thank you.
Okay, and of course, one of the wonderful things about Bentley was his ability to enjoy the science and the art and the beauty all at the same time. And so to talk a little bit more about that quality of especially the imaging and so forth, I'd like to turn this over to John Miller. John?
Thank you. Okay, I'll see how this works. About here? Here.
Right on your
In
chin.
front of your chin.
Here?
Touch your chin.
This? This?
Touch
This?
it. Touch the chin.
Have I got the magic? Okay, here it is, right here, right? All right. God, Bentley did not have to work with this technology, did he? Okay, this is good.
It's not as original.
I almost wanted to make a wisecrack as you were talking about. I thought you were talking about Match.com or something there for a moment. As you were talking about the, it's interesting in terms of the profound. I mean, this whole evening has been as illuminating as reading more about Bentley the last few weeks after Brooks had approached me about being on this panel. And it is interesting where there is that merging of science and art with Bentley. And as one reads some of his writing, he was very poetic. Again, I mentioned BPR, almost ethereal in his writing. And his connection with his work was in part scientific, but it was really in awe of, I think, just the profundity of just looking up into the sky, being in this, incredible landscape, but also, just the beauty of the snow. And it's the word design he continually uses. And of course, the word beauty, which has been coined often in his work. And so his relationship with this, as I think mine has been with my work, I can understand how he felt, or in some way that it was to have been able to persist for as many years as he did, over 40 years, photographing snowflakes. I talked with some of my photography students this morning over at Johnson. I said, maybe we should do some kind of a little project, sort of replicate some of what Snowflake Bentley was doing. We go over to the science department, talk to Les Kennett, maybe work with a microscope. But I said, there are some requirements to this. We'll meet some morning, early, and it's about 10 below zero. We'll be working outside in some kind of a shed situation. And once we make our negatives, they're going to have to be washed, but we have no running water, we have no electricity, so we're going to have to wash the glass plate negatives out in Mill Brook, and it will probably be around 10 below zero. And there were no students responded with interest. And I guess I found that as I read more about his accomplishment, I think working under such severe conditions, working often in isolation, working with very little acknowledgement for many years, although eventually, certainly, and well warranted, he was acknowledged in many extraordinary scientific collections. I mean, I was looking for the fun on the internet today, and in terms of science we always hear, but his work is also in the Metropolitan Museum of Art and the Museum of Modern Art in New York. So he did make it into the art realm too. But I think that as a photographer, and thinking about his camera, they were talking about bringing one in tonight. He was working with a double bellows camera, which, when extended, it was probably about 3 to 4 feet. And reading about some of the technology, he basically took the front lens off the camera, retrofitted a compound microscope, which folded at sort of the joint just below the principal stage that carried the slide, and twisted it horizontally, puts it in the front of the camera essentially, and takes the top optical piece off the microscope. I'm sure probably everybody here has worked with some form of microscope in elementary school or high school. And through making it relatively light tight, he is able to begin his experimentations with the camera. Initially, for the first few years, he had a very hard time trying to come up with the right exposures. And by the way, the exposures, he had, I don't think he had any light meter per se. His only light was sunlight. Remember, this is 1880s, no electricity, supposedly no running water at that point, directly into the house. So he's working under very minimal conditions. And then he discovers at some point, I'm not quite sure what his sources might have been, that by changing the aperture, because remember, when you have a lens on a camera, you can regulate what is called the iris diaphragm in the lens by increasing or decreasing the amount of light that will come in and expose your film. By removing his lens, he had no ability to even have an aperture per se, other than what was dictated by the lower optic on the microscope. So what he learned through a process of trial and error, that by taking a sheet of metal and cutting a number of differing diameter circles and putting them below the primary microscope stage, I believe between where the light was reflecting or coming through and about to hit the slide, he could change the aperture of the hole. And basically, for those of you who have long distance vision challenges like if you take your glasses off, if you wear them, I'm not going to ask you to take your contacts off, and you just take your finger and make a very small hole and look through it, all of a sudden you'll find your resolution and your ability to see is very improved. And that is because you've created a very small aperture through which the light is reaching your retina, essentially. So he learned the fact that by making a very small aperture, which, by the way, increased the length of his exposure, sometimes up to almost 5 minutes. Okay? It not only did it give him the most appropriate exposure for the glass plate negative, but it also increased the depth of focus because although these snowflakes were only 1/16 of an inch thick, conceivably, the distance from front to back in that 1/16 of an inch, or maybe a millimeter or less, was an immense amount with that extension on the bellows on that camera. But through the small aperture, it gave him much greater depth of focus, thus rendering these snowflakes very high resolution. The other thing that's interesting is by taking off the lens, you had no shutter. You basically would not have a way with which to regulate the length of your exposure. He basically just took a black card, put it in front of the lens, and then when he's ready to do his exposure, he just pulled the card away. But there was a great advantage to this, because when you have a camera shutter, or a lens, for those of you who ever use SLR cameras, film or digital, when you use a shutter release cable or whatever, you usually put some form of vibration or very slight resonance in that camera. But by having this camera perfectly still and just putting a card in front and pulling it away, it's an old trick actually used by photographers who paint with light. There's no movement in the camera. And also being located in the back hills of Nashville, part of Nashville as in Jericho, not further south, he was able to have very long exposures with no vibration, no tractor trailers, only sleighs maybe once in a while skidding by. But it's just an extraordinary process to consider what he went through and how he resolved, that is a pun by the way, how he resolved his final extraordinary images. It's an immense process where he pretty much was self-taught. He had one sort of a mentor, I think, living down in Philadelphia or somewhere who was, I think, was a commercial photographer, right?
Can't hear.
Okay, I'm sorry. Right. I can talk louder too, being in that professorial type. But I think basically his great. Can you hear it back there now? I'm sorry. How are we here? Is that better? All right. Okay. So again, through his very his persistence, he not only perfected what he was doing photographically, but he endured and continued to do this work obsessively, and with a vision and the will, continue this work for over 40 years and produce these glass plate negatives. A stupendous effort, and they're very great quality. So I think that's about it for what I'm right now. Thanks.
Thank you. I'm just going to swing around here, and we'll hear from Paul Sisson a little bit more about snowflakes.
Well, I think, first of all, can you hear me? Okay. I think Snowflake or Professor Bentley would be very happy tonight because he also tried to hold a lecture in Jericho during his time. And how many people do you think showed up at the lecture? I see 6, I see 5. It was 6. Someone else read the book too. 6 people showed up at a lecture that he held in Jericho. So he's very, very proud of his town and his community for people showing up. People thought he was a little cracked. I think we heard that before. People thought he spent a little too much time with his head in the clouds, like maybe some of the people on this panel might have done. I thought I would say a few things about maybe a few things you didn't know that I read. I learned a lot about Snowflake Bentley in the last couple months. So before looking at snow crystals, he looked at stars and planets by night with a telescope. So this was like when he was 10, 12, 15 years old. He loved to fish. He was a trout fisherman, fished in the Millbrook in Jericho. He measured the sizes of 344 raindrops. This was something that hadn't been done before. He used a pan full of flour and would run out in the rain during thunderstorms, during light rain, during drizzle to try to get different sized raindrops. And so this was done in, what, 1880-ish, 1885. And it took until 1940 or so for people to repeat his experiment and go on to develop equations to determine how much rain is falling from the sky. And that was actually done at McGill University, just to our north. He also kept records on the Aurora Borealis, the Northern Lights. He recorded 634 sightings in 49 years. So I'm just wondering, when did this guy sleep? So he was doing snow during the day. He was doing, you know, the planets. I think I lost it. Okay, yeah. He was looking at the planets and the aurora at night. He was a farmer too, so he was doing, you know, the cow chores in the morning and in the afternoon. So he was a busy guy. He also had a float in the 150th anniversary of Jericho, the founding of Jericho. He had a float in the parade with a big 6-foot snowflake on the back of it. So there's just a few things that I learned about him. We heard about his mother spending the $100 on the microscope. He had other people that helped him along the way. He had a photographer friend who was from Bridgeport, Connecticut, that gave him his first camera that he could start to experiment with photography, Henry Seeley. Professor George Perkins from UVM helped him publish his first scientific works in 1898, a study of snow crystals. The Smithsonian recognized the importance of preserving his work. Bentley sent a bunch of his photographs to the Smithsonian, and they were smart enough to recognize that this is something we need to preserve, and it was something Bentley was worried about fire or flood or something destroying his work. So that's why he sent a whole bunch of them down to the Smithsonian. And since I work for the National Weather Service, a descendant previously named the Weather Bureau, there were people in the Weather Bureau that were advocates of his as well. The Boston office of the Weather Bureau, when he would correspond to them with letters. So, you know, now we would talk on the phone or email or something like that, but so once a week they would be trading letters back and forth. And after he wrote his first paper, he sent a letter to the Boston Weather Bureau asking, you know, I could really do more if I had a copy of a weather map, because in those days there was no, you know, weather map. There's no internet. You know, I couldn't look like now. You can look at any map of anything in the atmosphere on your phone, but back then you had to get a map from Boston. So the Boston office would send him maps every day, so that he could correlate what he was observing with the snowflakes and his temperature data and all of those kind of things with the greater happenings in the world of meteorology, like what's going on in New York and Boston and Chicago. How did that relate to what he was seeing in Vermont? He also had an assistant at one point. And we have a descendant of the assistant that now works in our office. He's the chief of the National Weather Service in Burlington. But his great-grandfather, E.H. Nash, would help him change and number the plates when he was taking the photographs. And so Nashville, you kind of get the connection there. And now we have one working in our office, which is kind of interesting. And finally, the last person I just wanted to talk about was William J. Humphreys, chief of the Weather Bureau. Washington, D.C. recognized later in Bentley's life the importance of what he was doing, so he helped Bentley write his book, Snow Crystals. So there's a big sort of Weather Bureau, National Weather Service connection there as well. I thought the other thing I could talk about briefly, and I know we'll have time for questions soon, is the thing that fascinated me the most, being a weather forecaster, at heart was his description of where in the field of meteorology, where on the weather map he was finding these crystals. So he'd get these weather maps, which now you can download at your PC or whatever at home. They're all online, so I went online and downloaded the weather maps from, he got his first one in, I think, 1901, December 4th, 1901. So I looked at that map, and basically here's what he had to say about the weather maps. So generally speaking, the western quadrants of widespread storms or blizzards furnish the most beautiful and perfect forms. At such times, the wind is usually westerly or northerly, the barometer standing at 29.6 to 29.9 and slowly rising. The percentage of perfect crystals is likely to be larger when the snowfall is not too thick, not too heavy, and the crystal size is medium to small, rather than large. The character of the snowfall often undergoes quite an abrupt change as the storm progresses. So I'm thinking, okay, so what does this mean to me in these days? So why in Jericho is he getting these crystals, the perfect ones that he was after? And so the other thing he had to say is the best crystals do not occur, as a rule, during the most intense snowfalls or during extremely low barometer readings, but during medium or somewhat scanty snowfalls. So what does that mean to a present-day meteorologist and what's going on with the weather in Jericho? So if you're on the western side of a storm, meaning the storm is to our east, maybe it's a nor'easter off the coast of Massachusetts or something like that. So we're on the western side. That's the cold side of the storm. The warm side is to the east, toward the ocean. The humidity, the amount of water vapor in the air is a little bit less on the west side, a little bit drier. The temperatures are, like I said, are colder. And also, when the storm is to our east, the winds come from the west and ride up the slopes of the Green Mountains. And that is what we call upslope snow. And that's something we've been studying and forecasting, trying to forecast in our office. Sometimes it works out, sometimes it doesn't. But we're getting better at it. We're still studying it, and Bentley would be proud of us. He could probably tell us how we were supposed to do it. But, so if you can imagine the air riding up the slopes of the Green Mountains, it creates a cloud, a mountain-type cloud on the western slopes. And then you have moisture coming in from the Atlantic. So one thing he noticed was that the best flakes come when there are two layers of clouds. And we know that now as the cedar feeder process. Basically, the moisture from the ocean comes in way high in the atmosphere, say 30,000 feet above the ground, with ice crystals, and they start falling. And as they fall down, they run into this upslope cloud with the winds from the west going up the slopes of the Green Mountains. And so the combination of the ice crystals from 30,000 feet falling into the clouds at 3,000 feet creates this perfect growth zone for snowflakes. And the ideal temperature is about 5 degrees in the clouds. So if the temperature in the clouds is about 5 degrees, and you have this cloud seeding from aloft, and the moisture feeding in from the mountains, you get this perfect snowflake. And that's why in Jericho, this kind of snowflake is pretty unique. And he never found two alike. There was a scientist, there was a controversy back in 1988. Mark is laughing.
It wasn't me.
We could stir it up again. There was a scientist, Nancy Knight, who worked for NCAR, which is the National Center for Atmospheric Research, and she was doing experiments over Wisconsin, looking for cloud microphysics, looking at snowflakes and snow crystals in the clouds, and found two nearly identical. They have a photograph of these. Now, I looked at this photograph. You can find it online. Didn't look quite the same to me. But it was close, it was close. But Bentley knew that if he could get up in the clouds, he might find two that were alike. But I think, he was driven. Why did he do this? Why did someone do this for that long? What was he looking for? I think he was looking to see if he could find two alike. So what was his most important contribution? Just wrapping up. Before Bentley, there were just sketches of snowflakes. So people would try to, draw them, basically, what they saw either under a microscope or something, a magnifying glass. But that didn't last long. They would melt or evaporate. You'd breathe on them and they'd go away. So he was able to preserve these, forms that other people could then study. So it formed a basis for many more studies in cloud microphysics and snowflake crystals and so on. Finally, just a couple of quotes that I'd like to read about, I think kind of sums up maybe Bentley, at least to me it did. The first one, you have to have enthusiasm in the country to study science, and anyone who lives with that work and hopes to carry it on, well, all he has is his own enthusiasm. So he wasn't getting a lot of encouragement from the community at large, so he was driven by his own enthusiasm to study the snowflakes. Another one is a quote from one of his journals. We still have this journal today. It's called Monthly Weather Review by the American Meteorological Society. And he said, "In this inexhaustible storehouse of crystal treasures, what a delight is in store for all future lovers of snowflakes and of all the beautiful in nature." You would never have those words in a scientific journal today. You just wouldn't have the word beautiful because that's not objective, right? So it was just amazing. He was able to bridge the gap between the science and the theory with, the art, like John was talking about. And then finally, but always, from the very beginning, it was the snowflakes that fascinated me the most. The farm folks up in this North Country dread the winter, but I was supremely happy from the day the first snowfall, which usually came in November, until the last one, which sometimes came as late as May. I'm with you, Snowflake. Happy birthday.
As you can tell, there's just as much enthusiasm for snow up here as there was back in Bentley's time. So first of all, thanks for all of those remarks. And so I'd like to just take a few moments if any of you have any questions for any of our folks up here on the panel. Just raise your hand. Yes?
Quick question for Trent Gary. How long did it take for the snowflakes to sublimate? What was the window of opportunity to take a photograph?
How long did it take these snowflakes to sublimate? Anybody want to weigh in on that? Basically, sublimating means that they would dry up, literally. Okay.
I believe, just reading, I think Duncan Blanchard's book, that it could happen very quickly, and one of the ways with which he was able to lengthen that time, particularly with the more stellar design, or I guess they would call it the dendrites, that he would place a number of snowflakes around the flake which he was photographing in order to, I guess, keep it a little bit cooler and just delay the process of sublimation. Yeah. Great.
Mm-hmm. Yes.
I see large snowflakes that are widely dispersed and coming down slowly. I refer to it, like many do, as lover's snow. Did Bentley name any of his snowflakes other than categorize them by some number? Did he name his snowflakes at all?
Did he name his snowflakes? I haven't seen any reference to that specifically. Everybody's shaking their head, so. No. Yes?
I was wondering why all the snowflakes are hexagonal. What makes it come out as a six-sided flake?
Okay, this is something that Bruce was talking about, so maybe you can just kind of get that. Oh, I'm sorry. You go ahead. Repeat the question. Repeat the question. You can do that. Why are they hexagonal?
Why are snowflakes six-sided, hexagonal? Because of the angles between the two ears, the angle between the two hydrogen atoms, which is 105 degrees. And so to make the complete circle takes 6. And then that gives you 6 points. And then further growth takes place on each of those points. So always the original molecule is 6-sided, because molecularly it takes 6 of them to make the circle. And then after that, at each of those 6 points of that circle, that's where a new point will start and then start to spread off. And so then you immediately get 6 shafts of ice coming off of that original circle.
Back to the question about naming Susan.
Yes, Susan, you had something about the names?
Yeah, I know there were certain individual photographs that he had taken that he did name, like one that looked like a clock.
One that looked like a clock? Okay.
That he did, I think, that he took in Canada that looked like it had beer bottles, they were kind of shaped like beer bottles.
Oh, I've seen that one, yes,
And,
yeah. One that looked like beer bottles.
Yeah, and then he had some that I know he categorized them, but there were certain individual photographs that he took that he did kind of put a name to a descriptive term, but not a scientific term.
Right, okay. Right, thanks. Okay, so, yes, sir.
Do snowflake crystals live in flatland, or are they in 3 dimensions?
Oh, are snow crystals, are they flat or do they come in 3 dimensions? You want to handle that, Bruce? Yes, you do. I'm the moderator.
I want to be the moderator.
You got the microphone.
They're flat. Because the 6 sides then, they grow out horizontally. And if they have any 3 dimension at all, it's one little spur off on the end, like a branch of a tree might not be perfectly flat. But the original plate is a flat plate. And so if you look at all of his pictures, they look flat because they are flat.
I will mention one. There are capped crystals, and those actually are 3-dimensional. They're capped columns, and they actually look like they have plates on the top and the bottom, and then a column connecting the two of them. If you look through some of the images from Bentley, you'll find, in fact, I saw somewhere where he had mentioned that those are some of his favorites. So, yes.
In the article that was in the Free Press yesterday about the snowflakes, it said that the snowflake starts as a type of dust, a piece of ash, or something else, and I can't remember what the third thing was. But it makes you not want to catch a snowflake on your tongue.
So the question has to do with the nucleus that they form on. Maybe we can have Paul chime in on that.
There's a couple common nuclei. We call them ice nuclei. One is a clay. The clay comes from soils that are dry and the particles are dust that blow up into the atmosphere. The winds raise them up and they're transported all around the globe. They may come from a desert even. So those, yes, but they're like half a micron. I can't even describe what that is. It's just, it's not going to hurt you. You probably eat more dust than that on a daily basis. but the other thing that is a nuclei is salt. So from the ocean, the salt particles doesn't actually melt the snow.
Yes.
I heard that if a snowflake melts and it refreezes, it remembers, it has memory, it refreezes into the same shape.
If a snowflake melts and then refreezes, it remembers the original shape it was in?
It goes back into the same shape.
No, one of the things that happens is that the snow crystals are made from water vapor. So it's not liquid water droplets that are freezing into those forms that you see. It's actually invisible water vapor that grows immediately, basically from vapor, invisible to a solid. So snowflakes are not frozen raindrops. Frozen raindrops are those really hard little tiny things we call sleet. Okay. Oh gosh, I know. We're going to take questions for 5 more minutes. I know you have some maybe we can visit later. In the meantime, yes, sir.
One of the things that fascinated me was the thermometer, with the fact that at different temperatures the snowflakes look different. And that Bentley came up with that, and it was used by schools all over the world. Could you say something about that thermometer that he developed?
Okay, I'm not familiar specifically with the thermometer. Anybody? Sure. Paul says he knows all about the thermometer.
So when I learned, when I was invited to speak, my daughter for Christmas got me a copy of one of these Snowflake thermometers. And basically, Bentley, he also recorded weather data every day, the high temperature, the low temperature, how much snow fell, the barometer, the pressure reading, just about everything that he could do. So he would correlate what kind of snowflakes fell at what temperatures. And so someone turned that into a poster after the fact. But he knew in some of his scientific journal articles what temperatures were best for his snowflakes. And that actually, we're using that kind of information on a daily basis when we're trying to forecast the snow. It's something we look at, and I would love to have him here to see what we can do now. I mean, we would talk for all night, I think. But, you know, we look at the atmosphere in 3 dimensions. So at the ground, you know, all the way up to, you know, the stratosphere. And we search, when we're doing the forecast, we search for those perfect temperatures to produce how much snow we think we're going to get out of a given amount of liquid. We call this snow to liquid ratio, or SLR. So how much, if we're expecting an inch of liquid to be precipitating over Vermont, how much, what does that mean for snow? So we're looking at the temperatures, using his foundational work to determine, okay, we're getting 1 inch of rain, so that's going to be 10 inches of snow. That's sort of the standard, 10 to 1. But when temperatures are perfect and Bentley's perfect forms are falling, we can get as much as 30 inches of snow for 1 inch of liquid. I don't know if that makes any sense, but it's why snowfall forecasting can be very difficult, because the same amount of liquid can end up in a big difference in the snowfall. So it's very difficult to narrow down that temperature range.
Great. Thanks, Paul. Okay. Let's maybe just have one more question, because the cake is looking pretty good. Yes.
I wanted to ask you.
Oh, okay. Well, here. Let everybody in.
Okay. His activities must have had an impact on the farm. And how did the family integrate him in? And did people take up chores for him?
Actually, they did. Willie did. He participated in the work on the farm, the haying and the planting and digging potatoes. That was his specialty. There was a quote in Duncan's book about that. But really, his brother, Charles, and the nephews, as they got older, they really took on the bulk of the farm work. During the winter, there's not as much. It needs to be done anyway. But even in the summertime, when he was writing articles and doing lectures and preparing slide, copies of his prints for people that requested it, his brother and the nephews really took on a larger role. They did because they knew it was important to him. They never really truly came to believe in what he did. As I said earlier, they thought he was a little cracked and it was kind of wasting his time. But the nephews and nieces were very fond of their Uncle Willie, and they were more than happy to take on an additional share to kind of help out there.
Okay, so I know you probably still have questions and so forth, but I think we're going to kind of wrap it up. So first of all, please give a great round of applause for our panel. I'd also just like quickly to thank Brooks for all of his efforts at organizing this. It's just been an absolute delight myself to come back to Jericho. This is my fourth kind of official visit. I come through here more often than that, and that's lovely. Again, thanks everybody for coming out. It's a wonderful, wonderful turnout. Do you have anything else that
just a
you'd like
comment
to
or
add?
two,
Okay,
yes, of course, to thank everyone.
Brooks.
Thank you, Mark, as always, and particularly to thank our distinguished panel this evening. We also have, as John touched upon, some of Bentley's artistic photographs here. The one on my far right was in our Jericho Grammar School here in Jericho Corners for many years. He lived across the road from the Barrett family, which is now called the Range, the 40th and Allen Artillery Range. And he was close to the Barretts. There were 3 daughters, one of whom was our teacher I had for 4 years in the Jericho Grammar School. So it's now the property of the Jericho, fortunately, Historical Society. Then on your left are 2 of my, I have a number of things from the Bentley photographs, but this evening I wanted to bring one on cloud studies, which everyone touched upon, he was equally an innovator, seminal thinker on the importance of cloud studies with the weather. And then a recent acquisition is a marvelous image of, you can see his skills again, his technical skills, of Rhine on a window pane, probably photographed about 1910. Now we will have Miss Ann Squires do the deed. Ann? Yes, please. And then, yes, happy birthday. Let's play happy birthday to you. Please, everyone join in. Happy birthday to you. Happy birthday, dear Wilson. Happy birthday to you. And please, everyone, excuse me, yes.
A concerted effort was made some years ago by Blair Williams and Neil and Gene Smith to have a postage stamp made for Wilson Bentley, and nothing came of that, I guess because there wasn't any series he could be a part of. But it seems to me if Janet Joplin can have a
yes, I agree.
postage stamp, wouldn't it be possible perhaps to work through the Smithsonian for some clout, and on this 150th anniversary to spearhead something of that sort again?
Oh, thank you for your thoughtful comment. The Society is thinking about it, and we will approach first with the protocol. Procedure is through our distinguished, congressional delegation. I think we'll speak to Peter Welch perhaps first, and maybe Peter will be able to move some things in Washington, and then we'll go to the Smithsonian. Yes, there's a plethora of ugly. I think the United States produces probably the ugliest stamps in the world. And so let's hope maybe Bentley, we will succeed and have a snowflake on one of our stamps one of these days. Thank you, Bob, for bringing up this subject. Now we'll all enjoy Bentley's cake.